I've been getting a lot of flack from my loyal subscribers who want to see computer videos. So here's an old computer doing old computer things. So we're going to talk about the 1980 Suzuki project and where I'm at now and where I need to be. We're also going to talk a little bit about Japanese screwdrivers. Alright, so I got the engine out, as I talked about in my last video. We took the top end of the motor completely apart, and we discovered that the piston is completely destroyed. It's seized up multiple times in its life, and well, it's not really that good. Compression was a little low. Even though the engine ran well, the compression was on the low side, 110 pounds. Let's take a look at the engine. I stole this neat little tool cart from my parents' garage. My dad was going to throw this thing away. Can you believe that? Let's get a look at this engine. This is so handy. Just wheel it around the house. Okay. So I got the kickstand off. I removed the rear wheel. I checked the rear brakes. The rear brakes, by the way, which are original, as far as I can tell, are in perfect condition. But I did discover that and as I expected, the output shaft or the axle seal is leaking. There's a lot of buildup in here. It's like if you find that, there's like a greasy, gunky substance in the brake drum area of your motor scooter or your moped, there's a really good chance that your rear seal is leaking, or your axle seal. Normally you would just have a dry, powdery substance, which would be brake dust. That's normal. But when it turns into like a sludge, chances are that could be some oil mixing with that powder. Yes, it's a two-stroke engine, but like any other two-stroke motorbike that has a common case with the drivetrain is filled with oil up to about this bolt here with oil. In fact, I've actually drained this earlier today. There's no oil in it now. But what can happen is if this seal fails, that oil can leak into the brake drum and cause all kinds of cool problems with the rear braking system, and it can actually lose effectiveness. In addition to losing oil, which can cause the drivetrain to fail. Now this actually had really clean oil in it. I was impressed. I think it had been changed very, very shortly before I got it. It may have been just changed. And I looked down in the oil fill hole, and what I found was that the oil that is in there, if you just take a good look in there, I don't see any signs of heat damage. Everything is brightly colored. If it had run low on oil or run out of oil, you would find a lot of the metal gears and the chain and a lot of steel parts would be, they would have changed color. They would have turned like a darker bluish color, which they shouldn't be. So I think everything is good and kosher there. Now, if the crankshaft seal fails, here's another quick thing. I don't know if I touched on this in the previous video, but this two-stroke engine uses a unique. I don't work on a lot of two-stroke machines. I don't really work on a lot of bikes anyway. It's not really my thing, but I was surprised to find that the inner crankshaft seal, the one closest to the transmission, is open to the transmission side, where it gets lubrication from the transmission oil. And the seal that separates the two halves is designed to keep the oil from that bearing from getting into the crankcase. Now, if that seal ever fails, the engine will run, but it will burn not just two-stroke oil, but it will burn the transmission oil, because when it's in its intake stroke, the crankcase it's put under vacuum momentarily, and it would suck oil from this side of the engine. So if you find that your two-stroke is burning excessive amounts of oil, and you know the mixture is correct, and the oil pump, in this case, the oil pump isn't to blame, it's entirely possible that that seal could have failed. And on a bike that's 37 years old, any and all rubber seals should be replaced as a matter of course anyway. But just saying, if that seal were to fail, that is one of the symptoms. You would have unexplained high amount of oil loss in the transmission case, or a lot of excessive blue smoke. It can be hard to diagnose in a two-stroke, I understand, because they burn oil anyway, but you'd be dealing with excessive oil consumption. By that I mean the excessive amounts of smoke that result from the oil consumption. Now this bearing on this side is just fine, but now the bearing that's on this side here, behind the magneto, or the stator, that bearing is lubricated by this port right here. You can see it. That port right there. And there's a slight amount of vacuum that sucks or allows for the flow. It actually kind of like drafts through. So the fuel and oil mixture kind of is drafted through that hole through vacuum. And that is how this bearing is lubricated. And as I discussed in my previous video, there's a lot of buildup of sludge and deposits in that port. I mean, it's nasty down in there. And I do not trust that bearing, because it had been either oil starved or contaminated at some point, and that is really not good. So I expect this bearing, when I pull the engine case apart, I expect this bearing to have signs of heat damage, because they did find that there's a lot of buildup on the crank itself, on both halves, that could be the result of excessive heat. And a lot of it stems from poor maintenance, poor repair attempts, and definitely running too lean for too long. So I expect to replace all the crank bearings. I may even ship out the crank and have the connecting rod bearing replaced as well. It's a $50 expense, but you know, I've gone this far, why not do that? That is an option. I'm leaving that option open at this point. I can't inspect that bearing for heat damage because I can't see it. The only way to replace that bearing in the center of the crank is to split the crank, which requires equipment and experience that I do not have. So, where do we go from here? Well, in order to split the case, I needed to order some special tools. One of those tools is a crank puller. I'm sorry, a flywheel puller. It's a device that threads into. That's why this is threaded here on the inside here. It threads in. Of course, you take this nut off. Now, this is not this is a standard threaded nut. It's nothing special. You don't have to screw it on backwards. Take this nut off. You thread in this tool, and it has a bolt in the middle that when you thread that bolt in, it puts pressure on this crank here. This is the end of the crank, by the way, and it pulls or draws the flywheel straight off the crank without any slide hammer usage or anything special like that. But once I do that, I need to remove all of these screws. Now, these are actually long threaded screws. Now, this is where we're going to talk a little bit about special Japanese screws. They're called JIS screws. That's for Japanese Industry Standard, I believe. And they're more of a thing on Japanese vehicles, motorbikes, cars, power equipment. And you're finding them now on almost all Asian products, or at least industrial or heavy equipment type applications, cars, trucks, tractors, basically anything that was made, for severe service. I haven't really seen them on electronics so much, but I know they're used really all throughout Japanese industry and in even Chinese and Korean, possibly even Indian applications as well. The JIS screw is not immediately identifiable as anything special other than just a standard Phillips head screw. So most people don't even, at least in the United States, I would say the average person doesn't know what JIS is, doesn't know how to differentiate it from a Phillips head screw, and doesn't realize that using a standard Phillips head screwdriver on a JIS screw can damage it. It can damage the screwdriver, and it can damage the screw head as well. So what I'm going to do is I'm going to show you what these look like, how to spot them, and what happens when you use a Phillips head screwdriver on them. So the easiest ones to get to are these two. Now, normally JIS screw heads have an identifying punch mark on them, but some of them don't. So if you see a screw like this one here, you get a good shot of that one. You can see there's a tiny dimple right here. That's that little telltale punch mark. And that tells me instantly that that is a JIS screw. But here's another one. It doesn't have the punch mark. But you can, if you look closely at it, the center of the screw head is mostly square. You can actually draw a square right in the center of that screw. And you could almost fit a square-headed bit that you would find in American construction industries in that screw, but that's not the right thing to use. So if I take a standard number 2, or it might be even a number 3. I can't really tell. It's not marked. I think it's a number 3. No, that's a number 2. If I use that right here, see how the screwdriver wiggles? Now, if this screw is under any amount of torque, which is probably not, and see, I can get it off, because it wasn't torqued very high. Excuse me, very hard. I'm overcoming a bad cold, guys. But here's one that is. This is one of the crank bolts. Now, why they didn't just use 10 millimeter, I don't know, but whatever. Now, again, it doesn't fit very nicely. You might be thinking, well, what about a number 3? Now, this is a number 3, and we're going to try the number 3. More of the same. It doesn't quite fit. But in a pinch, it'll work. But if I put any amount of stress on this, it will I guarantee you it'll slip, and it's going to ruin the screw head, and then I'm going to have an even bigger problem on my hands. Oftentimes when you buy older bikes like this, they've been repaired many, many, many times over the many decades. I'm pretty confident that this case has never been split apart. I'm the first one to do this on this machine, so I'm good there. But if it was serviced in America by someone who did not know the difference between the two, or just used what they had because they didn't think to buy special screwdrivers, you're going to find that a lot of the screw heads are damaged for that reason. Now, I have right here, I bought a set of these on eBay. I can't buy them locally. I looked. Most shops don't even know what these are in the U.S. This is a set of Hosan JIS screwdrivers. I bought a complete set of them for 20 bucks, and I'll probably use them once. But check this out. Oh, that was a bad example. But very minimal. Of course, it's not going to fit like a glove, but let's check this one here. Tight as tight can be. I'm not putting any pressure on that screwdriver, and yet I'm able to tighten it with utter ease, and the screwdriver isn't slipping out. Here's another one. Or camming out is the term that you actually use. It's called camming out. When you twist the screwdriver and it starts to pull away from the screw, that's called cam out. And that's what these don't allow. Again, it's not the perfect fit because this is actually, I believe this is a number 3 JIS, but you get the idea. But I can still I'm putting a considerable amount of torque on this screw, and it's not camming out at all. I do the same thing with a number 3 Phillips. Put just even the slightest amount, it just cams out instantly. Enough of that, and you damage the screw. So it's important that if you're working on Japanese bikes, especially Japanese bikes, get yourself a set of get yourself a set of JIS screwdrivers. Now, for these higher torque bolts for the crankcase, though I can't split this apart yet, I actually need to get a T-handle, which is, well, it's exactly what it sounds like. It basically is a T-handle screwdriver that has interchangeable JIS bits included that allow me to put torque on these using the correct bit. You can even get JIS, you can even adapt them to be used with a ratchet or a torque wrench, which I'm going to have to do. And that is how you that's how you get these engines apart without screwing up all the bolts. Now, because I was impatient and I wanted to get this side cover off, and I'm glad I did, because I was so impatient, I actually used a pair of channel locks to get all of these screws off the stator cover. You can do that, but you will ruin the screw head, but you'll get them off. And I found that I really had to put a lot of tension on those channel locks to get those bolts out. I was blown away by how tight they were. And that's where the T-handle comes into play. I'm hoping that it works out for me, but there should not, according to the factory service manual, there should not be thread locker on these screws. So I'm hoping that, again, this is a virgin engine. It's never been apart. I don't expect anything like that. What I do believe, though, that I believe this cover's been off at least once. I know I have no reason to justify saying that, but so anyway, there you go, and that's where I'm at. I've got tools on order. I'm going to split this engine apart, and we're going to do it on this cart. I'm glad I have this, and this cover right here, I thought somebody spray painted this, which is why it was silver. I thought it was supposed to be black, but it's actually molded in color. It's molded in silver, and I thought that was interesting. You can still buy this cover. I'm going to do that. It's a little broken. While I can still get parts for this, I'm going to get as much of it as I can. I want to make this thing almost showroom new. And all this right here, this is very minimal corrosion. This is all clean. I'm going to clean this all up with a wire brush and possibly WD-40. And this is going to look beautiful. The side case covers, the stator cover and the transmission cover, those are all going to get recoated. I'm going to use alloy wheel paint for those, and it's going to look good. I think you guys might like it. So, again, quick lesson for the day, and this cover here, this is getting replaced. I can still buy this, and I'm going to buy a new one. So, anyway, there you go.